The lesson outcome for this video is I can add and subtract polynomials. You've actually already done some work adding and subtracting polynomials in the past, and that is because what adding polynomials is combining like terms. So we're just going to start with this first example, 5x squared plus 11x plus 13 plus 2x squared minus 8x plus 3. Before I add them, I'm just going to do a quick review of some of the terminology we've learned about polynomials. First of all, let's remember that this right here is a three-term polynomial, which means it's a trinomial, and our leading coefficient is 5 and our degree is 2. This polynomial is written in standard form because the exponent decreases from left to right. This is actually a very similar polynomial over here. We've got three terms. It's a trinomial, degree 2, leading coefficient is 2. The next thing I want to talk about with these two polynomials is that they have like terms. In this polynomial on the left, let's underline it in red, this polynomial has three terms. The first one is an x squared term, a term with an x squared for its variable part. And in our second polynomial, we also have an x squared term, 2x squared. Because they have the same variable part, they're like terms, so we'll be able to combine them. Next, we have an 11x in this polynomial, and we have a negative 8x in this polynomial. Remember, this minus sign can be treated as a negative for this 8x. So if you could think about it as adding a negative 8x or subtracting 8x are the same thing. We also have a constant of 13 in this polynomial and a constant of 3 in this one. So those will be able to combine as well because they are like terms. There are a lot of different ways you can go ahead and do the addition of these two polynomials, and I'm going to show a couple different methods. Some people will be comfortable right away saying, I know I can combine these and get a new result here. I can combine these and get a result, combine these and get a result without showing much work. And that's fine if you're doing that consistently accurate without having issues. But another way that you can do it, and I will show this method right now, is that we can take our first polynomial, 5x squared plus 11x plus 13, and we can do the stacking method. The stacking method means that we can take the second polynomial and put it underneath the first and make sure your like terms are lining up above and below each other. So in this situation, now we can just add these like terms. So 5x squared plus 2x squared gives us 7x squared. Then we have positive 11x and negative 8x, again being very careful about the signs, so they will add up to 3x. And then we've got 13, positive 13 and positive 3, and they add up to 16. So we have added the polynomials, and this is our result. In this second example on addition, I am going to use a different method, and again, some of you are comfortable just jumping to the answer right now, and fine as long as you are doing it accurately. What I'm going to do in this one is I'm actually going to rewrite it, reminding myself that if this is addition, we don't actually even need the parentheses. So I'm just going to write 9x to the 5th minus 7x to the 3rd plus x plus 6x to the 4th plus 9x to the 3rd. In this one, what I'm going to do is I'm going to do the work by underlining or circling or making some kind of obvious mark by anything that is a like term. Okay? So first of all, I'm going to underline this original or the front term here, 9x to the 5th. If I look across all the other terms, I do not have another x to the 5th term, so there's nothing to combine, so 9x to the 5th will stay the way it is. The next one I'll look at, I'll just go in order here, the next one I'm going to underline in blue, and that is negative 7x to the 3rd. If I look, I will find that I have another x to the 3rd term right here, and I'm going to underline that with the same color. I'm going to include the sign in front. So I have a negative 7x to the 3rd, and I have a positive 9x to the 3rd. So our answer is going to be something x to the 3rd. What we have to do is we have to say, okay, negative 7 and positive 9 add up to positive 2, so we have plus 2x to the 3rd. Remember, when you're adding like terms, you leave the variable part alone. You leave it the same. We're not multiplying as we did in the previous unit. We're not taking x to the third times x to the third. That is not what we are doing. We're adding the terms. So we leave the x to the third. All right, next we have plus x right here. Well, there's nothing else to combine that with, so I can just write plus x. And then we also have, and I could use a different color for that. There's no other terms with just an x. And then lastly, we have positive 6x to the fourth, and that doesn't have any other like terms, so we can leave that. Now to write our final answer, we should always write it in standard form, which means the exponents decrease from left to right. As you can see right now, we are not in standard form. So 9x to the fifth plus 6x to the fourth plus 2x to the third plus x is our final answer. Okay, now subtraction is the place where people make more mistakes. And that's because what we need to remember is that this polynomial, from this polynomial, we will subtract this entire polynomial, which means this subtraction sign means we have to subtract 6x squared, we have to subtract negative 3x, and we have to subtract negative 1. Another way of thinking about this is that we need to actually distribute the subtraction sign through the parentheses on the right. We need to make sure to subtract each part. What I highly recommend here is that you use one of the two methods that I show in these next two examples. The first example, I'm going to do the stacking method just like I did in the first example. So I'm going to start by writing my original polynomial, 2x to the second plus 5x minus 2. And then I'm going to write my second polynomial, which is 6x squared minus 3x minus 1. And then the important thing here is we need to remember to subtract the polynomials. To do this, to make sure you don't make mistakes along the way, what I recommend is that you change this subtraction sign to addition, but then you need to change every single sign for our second polynomial. Okay, so we're going to change it to addition, but we have to change each and every sign, so add the opposite. So we're going to make this a negative 6. We're going to make this negative right here positive, and we're going to make the last negative sign also positive. Now we just have an addition problem like we did in the first example. So 2x squared plus negative 6x squared. Well, we know we're going to be left with x squared. Negative 2 plus positive 2 plus negative 6 is negative 4. Our next terms are both x terms, and we have 5, positive 5, plus positive 3. Well, that will give me 8. So plus 8x. And lastly, we have negative 2 plus positive 1, and negative 2 plus 1 is negative 1. For the last example, we'll do another subtraction problem, and for this one I'm going to do like I did the second addition problem. I'm going to rewrite this as 6x squared plus 4x minus 9, and now you have to be very careful, okay? We're not going to be able to just put minus and then write all this. We will need to write, we will need to use the subtraction sign for both terms. Okay, so it's kind of like distributing that negative or negative 1 to both terms to the right. It is distributing negative 1 to both terms on the right. So we can think about doing that like this. So when I rewrite it, I'm going to say, okay, minus 4x squared. So minus 4x squared. And then, and this is where people will mess up, then minus negative 7x. Well, what's minus a negative 7x? Well, it's plus 7x. Be careful. All right, so now I'm going to go through and I'm going to underline like terms again. So here's 6x squared. I have another x squared term here. It's got a negative 4 as its coefficient. So we've got 6x squareds and negative 4x squareds. So we've got 2x squareds when we add 6 and negative 4. Next, we've got a positive 4x right here. There is another x term over here. It's 7x. So we've got positive 4x and positive 7x, which gives us 11x. So plus 11x. And then notice we just have one last term here, and that is a negative 9, and so just minus 9.